Pandas has a few ways of interpreting date times, or actually all programming languages have a few ways that they can determine date times. The most common one that you'll see, or a very common one that you'll see, is having the date time as a string. And so you can look at this string and think, oh, it makes sense humanly, right? I can see that's it's January of 2015, it's the first date, and that maps to some data value of 58. And so when we go ahead and we read this file, Pandas doesn't go ahead and automatically convert it to a date time for me. I'm using this read fixed with format function, but you can this also exists in read CSV. You can actually have Pandas parse the dates for you. You can have Pandas parse the dates for you. And so when you do this, Pandas will, instead of inferring this date column as a column of strings, it will say, hey, I'm going to try and make sense of this string. I'm going to try and store it as a date time. Additionally, Pandas is not limited to having a single column to a single date time mapping. It's actually very common to store dates as multiple columns or multiple values where you separate the year, month, and day. In a lot of databases and also, I would even argue, spreadsheets, this can be a very useful format and because it allows you to treat the year, month, and day as separate entities. We can have Pandas parse this as a single date. And when we do that, we can see here that we're actually almost concatenating these strings and then parsing them as if they were a single date. And you can see that my data types also come out correctly as a datetime 64 instead of an object data type treating the month, day, and year as separate columns. There is, however, another way that date times are commonly represented. We refer to these as epochs. And so when I go ahead and pass in this timestamp with a string type date time, you can see that it parses that and I get the exact date time representation that I put in. However, we can also pass in an integer. And if you've ever worked in Excel, this is very similar to how Excel works. If you've ever had a column either mistakenly as a date column when it should have been a numeric column, or if you've been using that general formatting column rule, you'll notice that sometimes when you put in a small value, you get out January 1st of 1970. All that is referring to is back when Unix systems first became widely available, they decided that storing date times as a string is a very big waste of space. We can store integers in a much more confined space than we can an entire string, just in terms of memory. And back in 1970, and even, before 2000, memory was very expensive and hard to come by, whereas nowadays we're kind of floating around. We have a lot of memory in terms of our personal computing power. And so all this is doing is we're representing a date as the number of seconds, standard seconds, since January 1st, 1980. You can see here by passing 100 seconds or 100 into the value of my timestamp, I get out January 1st, 1970, 1 minute and 40 seconds after midnight. And so whenever you run into these January 1st, 1970 issues, you'll now know that under the hood, there is something being interpreted as an epoch, as a Unix timestamp, that is being inappropriately conveyed, because typically we never really want, January 1st, 1970 when we're dealing with dates. And you can see that I can even perform the reverse computation. I can go from the May 1st of 2015 back into a timestamp, and I can do that again, If I supply January 1st, 1970, 1 minute in, we know that's 60 seconds after midnight, and so when I convert that to its actual POSIX timestamp, we get 60 out. Another thing that you should also be very careful about when you're parsing date times is what is the format of this date time. If I were to show you this date as an American, you would probably tell me October 5th, 2015. Dead stop. There's no other way to look at this. However, in Europe, I know, there are other ways that people read date times. So this formatting is actually ambiguous because people put the day first instead of the month first. America is not, unambiguous with the rest of the world. And so how do we resolve this discrepancy? Well, if your dates are mixed within your same data set, unfortunately, there is no programmatic way for you to unsort that. There are educated guesses you can make, but you'll never know, right, if this refers to the 5th of October or the 10th of May. But if you do know that your days come first when you're parsing these dates, you can actually pass this day first flag, and you'll see that this is correctly parsed as the 10th of May, whereas above we parse it as the 5th of October. I can supply this format explicitly, right? Instead of having to rely on day first, I can simply supply this format string, which is the exact same as Python's datetime module format strings. And so I can supply the month, right? And I can say that the first thing is a month, and then you'll encounter a forward slash. Then you're going to encounter the day, and then another forward slash, and then you'll encounter the year, and it's a capital Y because it's a 4-digit year instead of just a 2-digit year. Because you can also write this date like this. And if you're familiar with that, then you might be familiar with the whole Y2K scare, right? What happens when we go back to 00? Are all our computers going to think it's 1900 or 2000? And so when we apply this formatting, we can use toDateTime on a list of values. We don't just have to supply a single string in. This is actually made for parsing entire series worth of values. But you can see that as long as everything abides by this format, then we all work out. However, if I change this format, I get this value error, right? Time data 10/05/2015 does not match format month/year. That's because we have a day right here in the middle. So it's a good thing that when we do supply this format, pandas will actually let us know that it failed to parse the date time, and we should probably revisit what our dates look like. Additionally, if you have either kind of garbage input, instead of having an error propagate, you can instead coerce that value to NAT, right? And that's how pandas represents a missing date time. That stands for not a time, which is the synonymous with not a number, NaN in pandas. But if you don't want it to coerce, you can actually have it perform the default operation, which is raise that error that we just saw before. Time zones. Dealing with time zones as a data analyst is probably the bane of your life. If you deal with time zones, I pray that you can figure it all out because they are ridiculous to deal with. As a general rule of thumb, never, ever store data in a localized time zone. But what does localized even mean? What are all these time zones all about? Well, say we have just a few dates. If I know something about these dates, if I know that they were collected according to a universal timestamp, I can localize these date times into that time zone. And what this does in my representation of my date time, it adds this plus 00:00. That is because the UTC time zone has no addition or subtraction on the number of hours, since it is the kind of the basis that we use for time. At least in computing. If instead I know that these date times are stored in US or Pacific West Coast, this is PDT or PST, and we'll get to daylight savings in a minute. But I can actually supply in that my date times are actually represented in US/Pacific time zone. And so the difference here is that I've told pandas that these two same dates are represented in different ways. And the difference that we see here in output is, right, my UTC is the same date that I parsed, right, plus 00, whereas when I parse this as the Pacific time zone, we actually see the same date, right? Everything's, no hours past midnight or anything, but we get this -8. And that's because we're -8, we're 8 hours behind UTC. What is a very handy thing to do is if we know that our data is collected in some time zone, but we want to convert it to another, we can actually go ahead and do that. And so by localizing it, we take what's called a time zone or a naive date time. It has no idea what time zone it was collected in or what time zone it was stored in, but we can tell it. We say, hey, you were collected in Pacific, and now I'm going to convert you to UTC. And when we do that, you can actually see the difference here, right? Where this time zone, once I localize into Pacific, it has the -8 as part of its string. Or once I convert it to a UTC, it actually applies, right, that conversion factor, because we're now 8 hours ahead, right, of the Pacific time zone. So if I have some data and I know that it was collected and stored in UTC, I would probably want to localize it to UTC first. And then if I had to display it or share it with someone or perform some analysis on that corresponded to the actual the days in the Pacific time zone, then I would convert it. So localize first, that's where you're taking this time zone naive into an informed time zone, and then you convert it into US Pacific. Now you'll get, if you're not sure how your dates were stored, I would recommend just leaving it in UTC or just not worry about localizing it or converting it. If you do need to perform some date-time aware analysis, localize it to whichever dates or whichever way the data was stored, and then go about converting it. As long as you follow that pattern, you won't have too much of an issue, because you can see that you get very different results if I localize it to the wrong time zone and then convert it to the wrong time zone. Our output is quite garbage compared to when I localized it to the correct time zone and then converted it. And the thing is, you're going to be off by a factor of 8 hours or by a factor of 16 hours in your analyses, which if you are performing date-time aware operations or time zone aware operations, then you won't want to be almost an entire day off. Additionally, there are date times that exist that are localized that are not pleasant to deal with. These times all look pretty innocent at first, but when you consider that March 13th of 2011 was the day that daylight savings happened and we sprung forward, this means that this time never existed. Additionally, in the fall of 2011, on November 6th, we experienced 1 a.m. twice. And when you're going about your day, you're worried about getting an extra hour of sleep or losing an hour of sleep, and it's not that big of a deal. But when you're trying to perform time series or date-time aware analyses, this can be a big pain to deal with. And you can see here that if I just take these spring times and I try to convert it to a localized US Pacific time, I get a non-existent time error, right? Because 2 a.m. never existed. 2 a.m. and 1 nanosecond after existed, right? Because once our clocks hit 1 a.m., they spring forward. And so there's actually ways that we can deal with this. We can supply a non-existent flag to our localized call. And this will instruct pandas what to do if we encounter a non-existent date time. We can also provide instructions on, okay, well, if the date doesn't exist, just shift it backward to the previous date that existed just before that. We can also shift forward as well. Now, if we're going to go ahead, let's go ahead and look at these fall dates with the ambiguous times. If we try and localize them, we'll run into an ambiguous date time error, but just in line with the non-existent keyword that we passed, we can also pass ambiguous date time, so you either coerce them to not a time, or we can have it infer. And what the infer means is that look at my data. If this date happens twice, assume that this is the first time this date occurred, and this is the second time that we encountered it. And you'll actually see that I get a more proper parsing of my dates with the application, right, of daylight savings occurring after 1 a.m. on the 6th. The first one is before the first date time, the first 1 a.m. here is before daylight savings occurred, and then the second 1 a.m. here is after daylight savings occurred. And so Pandas has a lot of ways that you can deal with date times. It has a lot of ways that you can deal with time zones and perform all sorts of parsing and converting operations.